Alright, so I'm going to show you how to graph with Excel and add a trend line. So you've successfully opened Excel and typed in all of your data and all of your partners' data. So we have Scott, Susie, and Steve here, and all of their concentration data, all of their absorbance data, and their unknown. So the first thing we're going to do is we're going to look for this little button, the chart wizard. This is what's actually going to allow us to add the chart to our sheet. Now if you don't see this, what you want to do is just go to Insert and click on Chart. So this chart wizard comes up and it gives us all these different chart types. We want to add an XY scatter plot. So we click on XY scatter and we just want to do a basic scatter plot. We don't want to connect the dots or any of this stuff. We just want to do a basic one. Click on Next. Now here it's prompting us to add data, okay, because we didn't select any data. So the first thing you want to do is click on Series and click on Add Series. So we'll give it a name. We'll call it My Calibration Curve. And here we're going to add our X values, and here we're going to add our Y values. So for our graph, the X values are going to be our absorbance, and the Y values are going to be the concentration. So we just minimize this for the X values, click, hold, and select all our absorbance values. Make sure not to select your unknown. We don't want to add that in our calibration curve. Okay, so we just maximize that and do the same thing for our Y values. Go over, click, drag, and select all our concentration. Now in this little preview, we should see a little preview of our graph with all our data points in this line. We just go to Next, and here we have our chart options. So here's where we're going to just change and modify a few little things just to make our graph look nice. So the first thing we're going to do is we have a title, it's My Calibration Curve. We have to put units that are going to be along our X and Y axes. So our X axis is absorbance, ABS, which has no units. And our Y is going to be concentration, which is in units of moles per liter. And you can see now that we have a title here, or I should say a name here on the side that tells us what our Y values are and what our X values are. So really the only other thing I do is I go to grid lines and I get rid of the grid lines because I don't really like them. So we just click on Next, we click on Finish, and here's our graph. Just going to drag it up here, make it a little bigger, and there we go. So the first thing I generally do is I double click on this plot area and I change this fill color to no fill. Makes it a little easier to see, makes it a little bit easier to read, but especially when you print it out, it looks a lot better and it saves a lot of ink. Okay? So make that fill color no fill. So now we just want to add the calibration curve. So with our chart selected, we go up to Chart and Add Trend Line. So we want to add a linear, we want to do a linear regression on My Calibration Curve. So we just click Linear, and we click on Options, and we want to Display Equation on Chart and Display R-squared value on Chart. If I could click it, there we go. Click OK. Now that's it. So now we have the equation which is the best fit for our data points. And we have this R-squared value. Now what is the R-squared value? Well, the R-squared value is just simply a number that represents the goodness of our fit. Okay? It's how well this line corresponds to our data points. The closer it is to 1, the better. It's not an indication of error. We can't say that in our numbers that there's a 2% error. We can't do that. It has nothing to do with error. It's just about how well this equation matches our data points. Okay? So you want to look back at your calibration curve and say, are there any points that are way off the line? Well, in our case, there's one. It's this point way out here. Okay? So that is 0.421. So we go back over here and we see, oh, 0.421 compared to 0.136 or 0.168. So probably, Susie probably messed up here. Maybe she poured the wrong stock solution into the tube. Maybe she did her dilution wrong, whatever. But that's why we did these in triplicates, so that we can eliminate values if they're way stray off the line. So we'll just click on that, push backspace, push enter. Well, we can see that point is now eliminated from our curve or from our plot, our equation has changed and our r squared value has gotten a lot better. It's a lot closer to 1. Okay? So now what we need to do is we need to calculate the concentration of our unknown in moles per liter. So here we have our absorbance. So there's 2 ways we can do it. We can either just enter these values. So let's do that right now. So we just push equals 0.1204 multiplied by, and then we click on our cell, and it should be highlighted here, and you see C11 here, plus, minus 0.0016. And there we have the concentration of our unknown. Now these numbers here aren't the best, because what Excel does is it abbreviates these numbers. It cuts off a lot of the other values, or decimal places, just to make it look nice. Well, we want to include all those in our calculation, just so we get a better number. So the way we do that, and I'm going to do that right here, is we just put equals, and then we want it to calculate the slope inside this cell. So we go slope, parentheses. Now notice here it says known y's, comma, known x's. So we just select all our known y values, all our concentrations, comma, and then select all our known absorbance values. Don't worry about this blank spot, it won't count that. Close the parentheses, multiplied by our unknown. Now here we want to put a plus, because it's given it the general equation is y equals mx plus b. It just so happens this is a minus here because our intercept is a negative number. So make sure to put a plus here always, even if on your best fit line it shows a minus. We go plus, and then we type in intercept, parentheses, and the same thing again, known y's, comma, known x's. So we select all our known y's, comma, select all our absorbance values again, and there we go. And see, that is a little bit different. I think that's significantly different. 0.11695 versus 0.11694. So that's how you calculate the concentration of your unknown. Well, that's all good and fine, but now we want to print it off, okay? So this dashed line down here, these dashed lines right here, are the page width, okay? So if I just left it like this, it would print out 2 pages. One page would have all this stuff in it, and the other page would just have this. So the way we can make it print all this out on one page is just go to File, Page Setup. Now change it from Portrait to Landscape. Click OK. Now we can see those lines change. So the bottom of the page is here, side of the page is here. We just bring in our chart. Might have to shrink it back down some. That's fine. And there we go. Because now when we go to print it, print preview, this is how it's going to print out on the page. Okay? So I might have mentioned, no, I didn't mention, these numbers are not all the same, right? Because here we have 0.1998, 0.2035, and 0.1909. Well, they're not all the same because Scott, Susie, and Steve, they each made their own standards, their own stock solutions. So the calculations, or the concentrations, are going to be slightly different. So I'm not going to explain how to do that here, but if you want to figure out how I got these numbers, or how these numbers would, you would find these numbers for your calibration curve, you can just go to the website, sites.google.com/site/CoreyFugate, and look for a new page that I'm going to put on there called How To's. I'm going to write some things out, do some calculations, scan it in there. It'll be on there as a PDF within a day or so, and look for how to do that there. So I hope that makes sense. I hope that clears things up. So now everyone should turn in an Excel spreadsheet to me next week when you turn in your lab. There's plenty of places on campus that have Excel on the computers that you can use, or if you absolutely can't find anywhere, come to my lab, come to my office. That's Bilger 207 or 206. I'm generally in 207, that's where my desk is. But if you can't find me in there, look in 206. And you're more than welcome to use my computer, and we can print it out then and there. If you get stuck on any of this, save your Excel sheet and email it to me, and I can take a look at it. Alright? Good luck.